Welcome to Community Office Hours for Vault. I'm Rosemary Wang, a developer advocate at HashiCorp, and we're here with our guests today. If you have any questions or comments, we'd love for you to interact with us in the chat. As you do, please keep in mind our code of conduct in this virtual space. I know that we're online, but keep in mind you have to be welcoming, inclusive, friendly, and patient. Be considerate, respectful, and professional. You can always review our code of conduct at hashicorp.com/community-guidelines. With that, let's get started. We have two folks from the Vault team today, which is awesome. We have Stephen and Roy. So Stephen, if you could start and introduce yourself, and then Roy, if you can introduce yourself.
Hey, I'm Stephen Wayne. I'm a back-end engineer on the Vault core team.
Sorry, I thought Stephen was going to. My name is Hridoy Roy, and I am an engineer as well on the Vault core team. Glad to be here today.
Awesome. All right, so we've got a couple things queued up today. Some of it is Vault 1.8 related. I think we're going to just dive into the demos and or some explanation. We're going to start with Stephen, and then we're going to go into the one that I'm pretty excited about, which is Vault Diagnose as well. All right, ready to share your screen?
Yep, hey all. All right, so over the past few months, I've been working on improvements to Expiration Manager, essentially to avoid what can appear to be catastrophic failures in some sort of edge cases. So if you're not familiar, essentially the Expiration Manager is sort of like an automated bot that runs in the background in Vault, and it handles revoking leases on various secrets and whatnot that have been expired, not renewed, et cetera, et cetera. So to successfully revoke these leases, we basically have to pull them from the systems that they're stored on. So if it's a Postgres backing or something like that, you have to go out and talk to Postgres, and everything has to be properly configured along that path to be able to revoke the lease before you can sort of remove it from Vault. So in the past, Vault 1.6 and earlier, we would sort of, on failed revocations, we would sort of just use a dumb exponential backoff, try a few times, and then if none of those worked, we'd kind of forget about it, never to touch it again until Vault restarts. But one of the problems was when Vault restarts, then all of these leases, which could be thousands or potentially millions, depending on how Vault is being used, they're all just.
I think Stephen just cut off. All right. We're going to pause for a second until the connection resumes. I imagine it probably cut off a bit. All right, so let me just double check. We may or may not have questions on there. Stand by. Oh, there we are. You're back. Internet, everybody. Oh, you may need to unmute.
Oh, I'll reshare the screen about that. Sorry about that. I think my connection must have dropped.
No problem. No problem. It's happened. YouTube went down once. I mean, Fastly went, what was it? Another CDN went down once. We're all fine.
Rosemary, what was the last thing that you heard me say?
I think you were giving the background and you were on, I think, the second or third bullet. Let me see. Yeah, the second bullet.
Okay, is everything up and running again now?
Yes, it is. Thank you.
Okay, cool. So essentially, just in case some of this got cut off previously, we'd retry lease revocations that failed. We'd retry those a few times. Eventually, we'd forget about them until Vault started up again. But the problem was when Vault started up again, we sort of immediately tried to revoke all already expired leases. And so if you have many of these things in the system that can't be revoked because, say, the network between Vault and that backing system is down, or there's a misconfiguration or something like that, those are all kind of shotgunned at once, which consume all of our storage requests. And those failing lease revocations also tend to take a long time because they might, wait 30 seconds for a timeout a piece or something like that. So all of this sort of culminated in Vault could get into situations where you start it up and it's unresponsive for 20 plus minutes while it's trying to churn through potentially valid and potentially irrevocable leases. So prior to Vault 1.7, I just made a little diagram. Kind of looks like this. So the expiration manager kind of like fans out however many leases it has to revoke right now. That eventually hits our storage layer, but our storage layer is limited by max in-flight requests. But then other Vault components also need to interact with that storage layer. So essentially, Expiration Manager could overwhelm our storage resources, resulting in other parts of Vault not having access to them and slowing down because of it. So we, across Vault 1.7 and 1.8, we made a number of improvements to the system that are kind of outlined by this diagram. So essentially, the Expiration Manager puts a lease to expire on a priority queue now. That lease eventually gets put into a worker pool where the worker pool is kind of fed by like various mounts. And so we do that. So like a mount would be like one physical Postgres background or backend, or like one physical MySQL backend or something like this. And then on top of that, we have a fair sharing layer. And the idea here is that we don't want sort of bad or misconfigured backends to overconsume all of our resources. So if there's like, I don't know how it works behind the hood off the top of my head, but like say MySQL has one worker or something that can actually be doing work. We don't want to have 50 Vault workers or something waiting on that one MySQL worker. We would rather distribute that across like multiple MySQL backends, Postgres, et cetera, et cetera. So that's kind of the idea with the job manager and the fair sharing. And then the job manager also does sort of various bookkeeping, and that just kind of aids with observability for the sort of Vault operator or whatever. So if Vault's doing something that doesn't quite seem right, now there are some metrics around it, and then there's also an API, so you can basically see like as a breakdown per mount, which mounts have a lot of irrevocable leases, because like, you know, maybe you've got just a few distributed on various ones, but then a certain Postgres backend has like 10,000. Then that's a quick sign that maybe something is misconfigured there, and it's something to look at. And then on top of that, we're also trying to be a little bit more intelligent with how we allocate work for the leases that we determine to be irrevocable. So lease essentially gets marked irrevocable if it's failed a number of expirations in a row. And now being marked irrevocable basically means that we're not going to automatically retry it on Vault boot, and that should save some work. We do have a worker that sort of periodically and slowly goes through the list of irrevocable leases to see if there was like some transient issue. But in general, this should save a lot of basically compute on Vault start, and it should lead to the system being even more responsive. We've also slightly tweaked the exponential backoff when we're trying to retry a lease. Added some jitter to avoid like a thundering herd problem or something like that, which essentially is, you know, if I have one wave where I'm trying to expire 100,000 leases for some reason or whatever, all of those fail because the system was overwhelmed. We don't want to then try the exact same thing over and over again every time. We want to kind of distribute it to see if that can help alleviate the issue a little bit. So the expected outcome of all this work is basically you shouldn't notice anything as an end user, aside from if you were one of the unlucky ones that had Vault freezing up. That shouldn't happen anymore. And then behind the scenes, we're using resources more efficiently. There's more observability through the metrics and the API. And the potential delay introduced in revocations from sort of applying back pressure through the worker pool and job manager system, that shouldn't really be noticeable in the real world. And if it is for your specific application, that's also tunable. So that's all I have. If you have any questions, let me know, but don't have a demo for you, just a little bit of an overview.
Awesome. So one of the questions that I had is that, can you configure the exponential backoff in jitter? What is configurable as part of the newer expiration manager, if there is anything that's configurable?
Yeah, so essentially, and these are things that you shouldn't have to touch or even know about as an end user. They're just kind of there in case your specific application calls for them. But the main one to know about is you can basically configure how many workers we have operating on revocations at one time. So behind the scenes, storage has a maximum of 256 in-flight requests. So you can see how in the previous system, if we threw like 20,000 requests at that, everything else that needs storage is going to have to queue up in line behind everything while those 256 churn through it. So now we default it to consuming up to 200 of those sort of in-flight storage requests. So that way we can get through stuff very quickly, but there's still plenty of bandwidth for everything else. So that can be turned up or down depending on if you want to optimize it, but in practice, 200 seems to be fairly optimal.
Cool. And the other question is, where can you find resources on the telemetry that you mentioned for Expiration Manager? I know you mentioned there were some newer metrics that were added or something. Is there documentation or a reference someone can use?
Yeah, so that'll be documented if we haven't already sent that document live. That'll be documented with the rest of the telemetry, sort of in the usual spot. And I can give you the names of those metrics real quick if you're interested. So there's vault.expire.num irrevocable leases, and that's basically just a gauge on how many leases we've determined are irrevocable. There's also vault.expire.leaseexpiration.pending, which is essentially a per mount count of how many pending leases we have. So this can also be used to see like, okay, why does this backend have 20,000 pending and everything else is at 0? Like what's going on here? And then there's also, and that one's a gauge too. There's also vault.expire.leaseexpiration.workers, which essentially is a count of how many workers have worked on a specific mount. So you can essentially gauge how much work a specific backend has used. And again, those will be documented. I don't remember the URL right now, but they'll be documented with the rest of our telemetry stuff.
Awesome. Okay, I'll drop a note into the chat with the docs/internals telemetry. If folks are interested in the specifics, keep checking back on that page and they'll be updated. Awesome. All right, I don't see any other questions in the chat, so I think we can move on to our next demo.
Cool. Yeah, hello everyone. So today I'll be talking about the vault diagnose command. This is a new command that is going to be introduced in 1.8. So for the agenda for this small talk, we're going to be covering what it is, why should it be used? So what are the cases in which an operator or an end user would want to use this diagnose command? Briefly talk about how it works, just so we can talk about some of the details about diagnose without jumping into every single check individually, and then we'll do a live demo and we'll see how that goes. So what is vault diagnose? It's a command. So you can run vault operator diagnose, pass in a config file, and the point of this command is to provide a clear description of what exactly is working with Vault and what's not working. And it's especially tailored for cases when Vault is down. So if there is something wrong with your Vault server and you don't know what's going on, and we've noticed that oftentimes there's kind of a lot of burden on operators and end users in kind of doing this debugging process, and it's not always very clear as to like what the root cause is and what the root causes may be furthermore. So what this command does is it says it not only returns kind of failures that it detects, but it will also kind of output warnings on things that may or may not be problematic, and it will also tell you what's for sure okay. So, and we'll get into kind of how it does that in the third slide, I believe. Diagnose may also pick up on misconfigurations that impact performance or general infrastructure health, and we'll talk about that in the demo as well. So these are again going to be warnings. They're not necessarily going to be errors. The errors are going to be strictly related to, hey, Vault can't serve requests. This is most likely why, like 90% chance. So, okay, so why is Vault diagnosed? So what's the kind of the motivation here? The genesis for the command started into a survey of a list of Sev1s and Sev2s that came up with support cases, where it was clear that there was a lot of trouble with what like in diagnosing the root cause for problems. I will add also that these are echoed also by the open source community. I think there are a lot of requests that come in the open source community, from the open source community, around configuration problems and so on. The research that was conducted showed, from at least from what I know, at least 6 cases where TLS was misconfigured due to certificate issues or kind of misconfigurations in the listener stanza. One case of too many. This slide is not correct. One case where there are too few. The limit on open file descriptors is too small or too low, and that caused Vault to have problems. So please disregard this line here. And then there were many cases of just syntactical configuration problems in the Vault config files itself, which tend to get quite long and quite complicated. And it's very easy to like add an extra S at the end of API address or something like this. And it may be actually quite hard to debug these things, actually, it turns out. So these are some of the main culprits for hours of work put in by Vault customers, operators, and support. And so the goal of Diagnose is to really empower customers to proactively catch some of these common causes for Vault misbehaviors as they arise, and or quickly catch the cause for Vault misbehavior when Vault is down to minimize downtime during an outage. Okay, so I kind of thought about what I wanted for this slide, because why should we, like as end users, as Vault operators, care about kind of the internal workings of Vault Diagnose? Well, there are many checks in Vault Diagnose, and it's going to be hard to kind of talk through every single check. So I wanted to do an overview of what the diagnose command is doing, so operators will know what to expect sort of structurally, instead of trying to enumerate every single check. The checks will be enumerated in the Vault documentation. So what is Diagnose doing? Diagnose uses OpenTelemetry spans to store diagnostic information as it walks through 2 things. First of all, it will do static checks. So when you see the Vault Diagnose output, expect a lot of static check parsing. So configuration syntax issues, and then sanitizing listeners. So checking various fields in listeners. Do they exist? Are the TLS versions that are specified in the listener stanzas, for example, compliant or up to date, or are they, out of date, and so on. So it'll do these sort of static checks. So that's one part. And then the second part is it's going to mirror the run function. So basically anything as an operator that you would expect to happen, like, the barrier gets initialized, or storage gets initialized, or I don't know, the core object gets initialized. Any of these sorts of things, Diagnose is going to mirror those and do those as well, and kind of deep dive into those and see what problems may arise. So these are the 2 structural things that Diagnose is going to really be focusing on, that one can expect. Go ahead, Rosemary.
Yeah, so actually a question on this, because I noticed there's OpenTelemetry on here. I think it'd be interesting to learn a little bit more about why OpenTelemetry spans in particular, and also these the walking, like the tree here is very reminiscent of Terraform. I'm wondering if there was some overlap there, or if this was a completely different effort or had to be implemented differently.
Yeah, so to my understanding, and so I'm familiar with Terraform as an operator, but I don't know how Terraform is working under the hood. So I'm not sure exactly what you're referring to there, but this was kind of implemented as a separate effort. The kind of idea to use OpenTelemetry and use spans in particular came from, well, there are a couple motivations behind it, but one of the primary things is OpenTelemetry is very, very customizable and configurable, and kind of you can use it to integrate deeply with with actual server code with very low overhead. So one can take these concepts of spans and kind of attach them deep in the code base without kind of too much syntactical overhead and so on. And also it's very kind of the implementation of OpenTelemetry and spans and so on. We found it to be quite aesthetic and quite simple in terms of code cleanliness and so on. And so it was mainly, at least from my perspective, from what I know, is mainly that sort of decision, developer decision there. But yeah, I think the second question you had was around the tree structure and how that works, right? So the tree structure, the reason that comes up is because we, like, as diagnose runs through the run command, it will deep dive on particular sections. And so kind of a span may be open to keep track of storage problems, like at a top level, at a high level, like what are the main issues of storage. But diagnose will also open subspans to keep track of like TLS related problems with storage, or like, can the actual backend struct be created properly or instantiated properly? Are there going to be some sort of like low level errors there? And so each of these things will be documented as a separate span and the errors and the warnings and so on will be returned separately when the tree gets walked at the end. And so the kind of meta point there is operators will now get a very clear, like we'll get clear insights into not just like storage isn't working and here's the specific reason why, but like clearly like in the TLS section of storage, my cert is, there's an extra PEM subsequence in my cert or something like this, which is kind of extra communication that OpenTelemetry and span nesting allows us to do, which is nice.
That's awesome. We have one question in chat, and you can tell me to hold off on that till after
Sure.
you demo. But one question was, could Vault Diagnose be baked into your Git workflow as a way to validate changes if you use automation to manage your Vault cluster?
Yeah, so Vault Diagnose has a JSON output format, which you can probably consume programmatically. However, one thing that we focused on when we were creating this Vault Diagnose command is to make this very human-oriented and human-readable. For example, the language in the diagnose output is going to have like full stops at the end of sentences and capitalizations and so on. We were really trying to gear this towards a human is reading this, and we want this to be kind of, yeah, as I said, human-oriented and not machine-oriented. However, you should be able to do so. There's nothing that comes to mind off the top of my head that will stop you. But again, not necessarily the primary focus of the command. Okay, so I'm going to continue here. Spans can be nested. We talked about that. I wanted to mention timeouts. So again, sometimes when Vault actually times out from like when you run the server, these timeouts are not necessarily very descriptive. Like what's actually the thing that's timing out? There was a situation where auto unsealing often times out, and then there's not much information on that. But here in diagnose, timeouts are caught and wrapped into particular spans, and you'll get much more detailed information on what exactly is timing out. We may not know why it's timing out, but we will know clearly, oh, it's auto unseal timing out, and so that will shave a lot of time from debugging. So yeah, and so the final bullet point here is diagnose walks the tree, and it will, as it walks the span tree, it's going to kind of output in human readable messaging what's going on. So hence the tree picture on the side. Okay, cool. So now let's jump into the demo. Okay, I'm going to try to move my Zoom windows from various places. I'll move it to the bottom. Maybe the bottom is not wise. I'll move it there. Okay, so this is a config. It's a very small config, but it's a perfectly valid config. One should be able to use this config and run Vault in server mode, and everything should work fine. So let's see what happens when I run Vault Diagnose on this config. Yeah, perfect. So called it. I don't even know what I called it. Diagnose minimal. Yeah, okay. Cool. So this is our first interaction with diagnose, and we see that it's failed. Well, this is kind of odd. It should work. We see that in check storage, there's a failure in particular, and we see that it's because in check storage access, we couldn't actually put a secret in. So what is check storage access doing? Let's hone in on this for a second. Check storage access actually tries to, after storage has been initialized, it tries to actually put a dud secret into storage itself. And we're seeing that, well, the storage config is actually looking fine, but put isn't working. And so this should clue an operator into this idea that, okay, well, my config is fine. I mean, diagnose isn't saying anything like the TLS is skipped, direct storage access is warning, but nothing necessarily, there are not any extra failures here there are no subspans with failures here. So things should be working. Why is it not working? And in this case, it turns out that console is actually not running. So let's actually go and run, use this config and run Vault and start up console as well. And then maybe we'll get something, maybe we'll get something, a passing run for diagnose. So let's see. There are a few sleep statements here, so bear with me on those. I didn't realize the sleep statements would be so poignant. Okay, good. So it worked. So this is good. We can try to get a secret, and I've written the secret in the script, and we can see that, okay, Vault is operational. I can do a Vault status, and everything will be happy. So now let's try to get this thing to work. Oh, it still fails. Why does it fail? Well, we can hone in on that, and we can see, okay, in start listeners, we actually can't initialize a listener because the bind address is already in use. This gets to one of the key components of diagnose, is that diagnose should be run when Vault is down. Otherwise, it's not really going to give very valuable information. In this case, since Vault is initialized, we can't actually bind to that port that's specified in the config file. So we have to kill Vault. So this is going to mimic the case when Vault is down. Oh no, Vault went down. Who knows why Vault went down? I have no idea, right? So now we're going to try this again. And what happens? Well, we see that everything is successful. Vault is down, but the config file seems absolutely fine, as it should be. This should cue the operator into knowing that this config file is totally legit. And if Vault is down for some reason, most likely you should just try to start it back up and things should be working fine. Storage is fine. The seal stanzas are okay, and so on and so forth. Okay. So let's try something else. Let's try to misconfigure storage. So here I've got console, storage console, but my address is some other address on which my console agent isn't bound. So what happens when we run this? This is diagnose misconfig storage. Okay, so cool. So here we can see that again, check storage, and we're seeing that the connection is refused here. And so again, we can immediately hone in on this idea that there's something wrong with either how storage is set up. So this should cue the operator into the idea that either something is wrong with how storage is set up, or for some reason, the actual connection to storage isn't working properly. That's a bit of a boring example, but it's the second one. Let's get into something a little more exciting. So this third configuration is nice. Here we've got TCP/P, this extra addition of a P. And so I want to pause here. This is a bit of a toy example, but one could get much more complicated files where it's very, very easy to make this sort of mistake. And I've forgotten what I've called this again. So I think I've called it syntax config 2 for some reason. Syntax config 2. Yeah, and here we can see that diagnose just stops because it says in the parse configuration section where we're looking at syntactical problems, we see that we couldn't actually even load the configuration because parsing the listener didn't work, unsupported type. And so diagnose just exits out. It says that, and diagnose will often do this. If diagnose thinks that a particular error is so critical that there's no point in even continuing, it will stop. And so in this case, it stopped and it's kind of clearly alerted the operator to the problem. Maybe something a little more subtle. Here we've got the operator has added telemetry in, but they've left in a value that shouldn't necessarily be here. It's called bad value. This is not necessarily a problem. It may be just fine, but it's not something operators would want to leave hanging around. And if telemetry is behaving badly, this may be a problem. Okay, so we do this again. And yeah, so again, this looks fine at first, but if we look into parse configuration, we see that there's an unknown or unsupported field, bad value, which is the field name, found in the configuration, and it will actually tell you the particular line at which this value is. So the operator can go and see, oh, on line 16, I've got this bad value line. This is not great. And they can remove that. Okay, let's add in some HTTPS. So here, similar thing, but we want console to be started with HTTPS, but these certs are expired. So what happens in this case? Well, it should be exactly what we expect, but let's run it, diagnose expired. Yeah, so here we can see that there are quite a few failures. Check storage fails because the leaf certificate has expired or is not yet valid, and it tells you what the current time is and what the expiration time was. We can see here that some other things fail. In this case, that same certificate, those certs and keys are used in service discovery as well. They're automatically picked up, and so we'll get similar issues with console service discovery. So yeah, so this is kind of what we expect. And finally, with good HTTPS, just to make sure that a good file kind of works out. Yep, and here we can see everything passes besides check storage, and this is just because I have not configured console to use HTTPS. Console is kind of at the default state. So, but this will pass if console was configured properly, which I haven't due to laziness. So, so yeah, that's kind of the end of my demo. We can talk about, I'm happy to talk about any of these checks in more detail if anyone's interested in those. I decided it may be a little too much to go into every single one of them. So, yep, that's it for me.
Awesome. Yeah, so a couple questions about the checks themselves. Are you right now, are you able to customize which checks will show as part of the tree? So for example, could I suppress warnings or just show failures? Is there any capability to do that right now?
Not right now. There's no way to actually specify. Yeah, there's no way to suppress things. Yeah, but we might want to add that in. That sounds pretty valuable.
Yeah. And the other question is that, is there a possibility that someone could extend this, right? So there's a couple conformance tests that are more general to any vault better practices, best practices. But if someone wanted to be more specific and say, like, we are going to, I don't know, for our system specifically, right? We have to have some kind of specific rule or specific, I don't know, expectation or test that we want to make sure that works. Could they add it in the future to Vault Diagnose?
There's nothing that comes to mind off the top of my head for like a customer hooking into operator diagnose. So probably the answer is no. But again, we've got that JSON format output, which you can use to grab, and then kind of based on various if you parse that out based on various stanzas that you get, you can you can write some particular checks on top of that, I suppose. But currently, this is like as all top level commands of Vault is, that it's kind of in a file in the actual code base itself. It's not necessarily a plugin, so it's not something we can extend.
Yeah, it reminds me a lot of Kubernetes conformance tests, which you're able to run on any Kubernetes cluster and determine whether or not it's conformant to sort of the functions that someone would expect it to use. So for those who are more or less familiar with the Kubernetes conformance tests, the Vault diagnose tests are preset. I will say I've been the person who accidentally added the extra P or the extra S to Vault config and not noticed it. So this is particularly useful. All right, we have a question in chat. Does or could diagnose prescribe steps to correct a problem and ask you to confirm that it should make the change that is prescribed?
So to address the second part, we don't do that right now. So diagnose doesn't go and actually modify the config file or modify any kind of Vault setup. That is a very interesting idea. We do have advice though. So in fact, this purple statement at the top here is advice. This is due to my own, this is a dev laptop. And so I've got too many files on this thing, but in an actual prod environment, you would want to have you would want to have your partitions relatively free. So one of the checks this is doing in the disk usage checks is it checks all the partitions and it says what partition is too full. And so if diagnose thinks there is something that's too full, it does give you some recommendations where maybe free up some space if you can on a particular partition. So it will offer advice, but currently it won't enforce advice or take that sort of action. And you can kind of see how it might be a bit dangerous to do so. But again, so that would be up for a discussion based on community feedback, customer feedback, and so on. But it could be dangerous, especially in these cases where we would have to make changes on the host itself. It's probably pretty scary to do so.
Awesome. Yeah, so I'm actually curious about the check storage check that you have there. So does it matter if, let's say, is it any Vault storage will be supported and will have this detailed information, or is it only currently the console one, for example, has this level of detail?
Great question. So we have a couple of generic storage checks, but the detailed storage checks that we've honed in on are integrated storage and console. So Raft and console are the two ones where we've got you'll get the most value out of diagnose. Those are the things that we first of all, we have the most control over, and second of all, we can kind of peer into the most, right? We won't necessarily be able to peer too far into MySQL or something like that, but we will be able to peer into in-mem or excuse me, not in-mem, into integrated storage. So yeah.
Awesome. I think there's a feature request in the chat. Could there be a marker labeled advice so we can grep those lines?
Yeah, we were actually debating whether or not we want to have a marker for it. So yes, we absolutely can. I don't know if we can do it or we will do it for 1.8. But again, depending on feedback and prioritization and so on and so forth, it's technically I can comment on the technical side. It's certainly possible to do, and it may be very helpful or not.
Awesome. I'm looking at some of the other ones that are skipped here. Can you go into a little bit of let's say what's checking for the auto and seal stuff? Or more importantly, I guess, let's say, yeah, just specifically auto unseal.
Yeah, absolutely.
Skipped here.
Yeah, so as we know, Vault has seals, and currently diagnose won't go through the pains of actually decrypting storage. That being said, it will be able to create a storage object under the hood. So instead of going through that whole storage stack, it'll get a storage object and it'll be able to do operations on that. But in order to check the seal stanzas, all it can really do for like a Shamir seal is unless, so there was one option where for a Shamir seal, you supplied the keys to diagnose, but there was no really secure and clean way that we wanted to release that for 1.8. So in which we were thinking of releasing that for 1.8. So we decided diagnose won't be taking actual, Shamir keys. But what we can do with the Shamir seals is we can create the Shamir seal and finalize it, and we can check that actually succeeds. That will always be there even when there is no Shamir seal specified. But in the case where the auto unseal is specified or used, we can do a lot more interesting things. So we can, this step here with, where's the auto unseal skip stanza?
Second to last line.
Yes, thank you. Yeah, so we can, so in the auto unseal case, we can actually create the barrier and use the barrier to seal, use the barrier to encrypt and decrypt a dud value and make sure that the keys are there and so on. And like all of that works fine. So again, we're not going to be using this in a production-y way, but we will be testing it to make sure its capabilities are all there. And so for a little context on that with auto unseal, a few of the SEV ones that came in were around like the keys simply not existing in a KMS. And that actually turns out is quite hard to catch. But this will immediately cue an operator in that there's something wrong with the keys. It may not be necessarily that the keys are not there, but they will know to look for the keys, sanitize the keys and so on. And that will be a lot less of a process than going through all of vaults, right? So
that's interesting. Yeah, I know you mentioned some of the SEV ones involve TLS certificates. And it's not, I imagine it's not in these examples because they're minimal examples, but can you explain a little bit about some of the checks for TLS that are built as part of the command?
For sure. So we have a whole host of TLS checks. We've got, of course, whether we've got certificate expiry, we've got whether the keys and certificates match. We check the certificate chain, if there's a certificate chain all the way up to the root. We check that intermediates and roots and such are all should belong in the chain. If there's something that we kind of flag like that's suspicious, for example, if there are like 2 leaves in a particular file, we flag that as a warning. It's like, hey, maybe is this a problem? We don't know if this is a problem for you. Are you sure you want this? And then of course there are some more complicated and more kind of esoteric checks with like extra PEM subsequences that may exist within a certificate. Basically, if a certificate gets malformed in some way or other, then there are checks for that. There are also client certificate checks. There's key usage checks on the certificate, and so on. There are a lot, so I can't possibly elaborate them all, but those are some that come to mind off the top of my head.
Awesome. And as you update some of these checks, where are you getting? So I know some of them are likely from the reference architecture or best practices. Are there any of them that you found as part of Vault Diagnose that you're like, oh, we should really do this, and it should be a best practice documented somewhere?
That's a great question. And so not necessarily. So so I guess there are two kind of classes of checks that I'm thinking of here. One class of checks are sort of the OpenSSL style of checks where they're sort of standard crypto checks that one would expect from an X509 library or OpenSSL or any such tool. And so those are not Vault specific, those are just generic best practices. And then there are Vault specific checks. Those will be documented in the diagnose command documentation. Those are like, those oftentimes are not actual checks on the certificates and keys themselves, but rather on like the listener, when like a listener is configured with a particular certain key, there should be the ciphers, the version for your TLS should be like above a particular version and things of that nature, which are Vault specific asks. So those are the two sort of classes of checks that I'm thinking of here.
Awesome. So I don't see any more questions in chat, but I think it might slow down. So we might wrap up early today. If you could unshare your screen, awesome. If anybody has any questions, feel free to post and discuss. Vault Expiration Manager is already available. Please correct me if I'm wrong. The changes have already been pushed as part of 1.7, as I recall. And 1.8, Vault Diagnose. Is that in 1.8? Okay, yeah, it will be in 1.8. Yes. Awesome. So for those who are tuning in, we appreciate you asking questions and participating. If there's anything you're interested in seeing in, it seems like there's a lot of folks who are particularly interested in customizing Diagnose. We appreciate your feedback. Definitely reach out and let us know. We have more community office hours this week. The next one will be Thursday. It will be for Terraform. You can check out our schedule at hashi.co/office hours. And then we also have HashiConf on October 19th to 20th. Feel free to register at hashiconf.com/global. With that, I think both the Vault engineering team in general for participating in these community office hours. And I appreciate the two of you for coming and demonstrating some of the capabilities that you've been working on. And with the community, definitely let us know if there's anything you'd like to see topic-wise on community office hours. Thank you for joining us today. Be sure to subscribe if you would like more content and you want to tune into more office hours.